Okay, problem number 2, another differential equation. We're doing a little research, and a lot of the practice problems for the BC for this year have been series and differential equations. So I'm crossing my fingers and hoping they show up for you. I hope you feel the same way. We've done a lot of them. I know this is pretty similar, nothing different in this one. We got this differential equation with landfill and tons and time, 1400. The first question was to use the tangent line at t equals 0 to approximate the amount of stuff in here at time equals 1/4. So at time equals 0, we have this point, 0, 1400 tons. So time is 0, 1400 for W. And then the slope, to find, I'm just trying to find the tangent line, right? So I need the slope, just plug in 1400 to this. 1400 minus 300 is 1100, so I got a slope of 44. So I get W minus 1400 equals the slope 44 times t minus 0. Do a little simplifying. I get W equals 44t plus 1400. I'm supposed to use that to approximate W at 1/4, so I plugged that in and got 1411 tons. Part B is find the second derivative, just implicit differentiation, and then use the second derivative to determine whether your approximation here is concave up or concave down. So the second derivative is just the derivative of this, constant, so it's just 1/25 W prime. 1/25 W prime, but W prime is that. It's like implicit, you got to plug it back in. So 1/25 times 1/25 times W minus 300. I did some simplifying. I got, or not simplifying, I guess, just multiplied that out. 1/625 times W minus 300. We're doing this when W equals 1400, right? Back up here at time 0. Because we're using the slope at 0, so put that in there. That turns out to be a positive number. So second derivative is a positive number, which means it's concave up, which means our tangent line, which we're using to approximate, is underneath the actual point. So the tangent line is an underestimate. And then the last part of this problem is straightforward. Just solve the differential equation. Nothing tricky here. It's a separable differential equation. The W minus 300 comes down here with the W's. Constant stays there. Integrated this, natural log of W minus 300. Integrated this, 1/25 t plus c. What did I do? I exponentiated both sides, so I got W minus 300 equals e to the 1/25 t plus c. Then I did that little trick with the constant up there. E to the 1/25 t plus c is the same thing as e to the 1/25 t times e to the c. And then I just called that a constant. I brought that 300 over there, so some constant times e to the 1/25 t plus 300. Now I want to find c using my initial condition of 0, 1400, so that's 0. So that just becomes c, because e to the 0 is 1. So 1400 equals c plus 300. c is 1100. Plug it back in. 1100 e to the 1/25 t plus 300. So pretty straightforward differential equation problem there.